So we now continue the discussion today, which we have started yesterday, and as clarified in the first lecture itself, that we will be adopting a sequence which is not given in the syllabus but which is useful for understanding. Syllabus on paper is a classical thing, and the classroom sessions are lively things. Everything lively need not go in the classical way. I hope you understand it. So now we are talking about signals, and today we will proceed with systems. Yesterday only we had clarified beyond doubt that a continuous signal or analog signal, a signal is nothing but mapping of one variable into other variable. In most of the cases it is real life variable with real time. So suppose if you are a person, then you are able to sense temperature. So you sense temperature at every instant. So temperature versus time is a continuous signal. You record the temperature each at 1 hour on a scale by marking it with some pencil. That is discrete signal. Means in continuous signal you continuously perceive a continuously varying thing. Listen very carefully. In continuous signal you continuously perceive, you always experience, as long as you are there and you are living, you always will experience some temperature. After some time it will cease to have an impact on you, but you will continue to sense. So you are continuously perceiving the value of a continuous variable differently. Every time it is sensed. Discrete variable. You are recording. Now you have stopped continuously perceiving. You are only interested in recording the variable at some given time instances. That is sampling. Sampling theorem is there, which we will be discussing in due course of time. So you sample them, you record them. Remember, it's most important you record on a linear scale by putting a point. So at 8 am, some value, you put a mark. So the length from origin to that mark is the temperature at 8 am. Length from origin, if it is on a vertical scale, it is 0. Then length from origin to this mark is 8 am. At 8:30 it is this mark, 8:30 am. These are the markings of temperature. Remember that these cannot be expressed by using numbers. These are variables expressed by T1, T2 like this, T0, T1, T2. So the lengths are representing their values. So these are discrete variables. Then when you want to communicate from one place to other, how will you communicate? If you take, when you come on camera, it is digital. Right now that is not the issue. So when you want to communicate, you put a scale of maybe 1 centimeter resolution if you are crude, 1 millimeter resolution or half millimeter resolution, or using a vernier you can go to 0.1 millimeter resolution. So you express the sample values by using finite number of digits to describe. That is digital. Continuous, it is also said as analog, then discrete, which is sampled, and then digital. Continuous, now these are types of signals. So continuous or analog, discrete and digital. Continuous things happen in nature. Continuous things happen in nature. Suppose if it is just like, what is system then? So if it is put on one fixed fixture, I am pressing it, and on other end there is something. So I will press something from here, the other end will also experience some pressure. So this unit it's a very simple mechanical system. A mechanical system it is fixed here, but when you press here, so just like say a striker on a carom board, you can have a striker in between. Put it by hand here. If you one striker, put it here like this and hold your hand. So striker is fixed. So using other striker, you hit here, and there is a piece. That piece will get displaced. So this force is input. This will exert the force in output. So in real time, there can be n number of variables. Actually, systems made up of physical components. In a RC circuit is one such. RC circuit is one such. Then jack, pump, all these things are systems which work on actual parameters all time. These are continuous systems. These are continuous systems. Then, because of advancements in computer, you may be, I don't know whether you are aware of any kind of bass and treble mechanism on your, what we can say, music player. In amplifier there is a volume that with that you increase the gain, but by bass and treble you selectively amplify or attenuate few features of the sound. Then bass treble is considered to be rude equalizer. Then you may be aware that you may ask your parents around 20 years back, when digital things were not so readily available. That time the advanced musical systems used to have equalizers, 3-band equalizer, 5-band equalizer, 7-band equalizer, where you could selectively amplify the components in different frequency ranges. So that is very interesting thing. The next is when digital things came. Now nothing is processed in analog. Everywhere there is recording. Recording is converted. Recording of speech, recording of any other temperature, any information, any physical happening means in continuous systems, everything takes place through maybe electrical appliances, something converted to electricity. Say the conventional analog amplifier system, a mic, the pressure signal is converted into resistance, that is supplied by power supply, gets converted into electrical signal, that is amplified using transistorized op-amp based amplifier, and that goes to speaker, again converted to pressure signal. So only through it means happening was converted into a happening of any parameter was converted into electrical thing, processed, and again reconverted to that physical phenomenon back. That was in case of continuous thing. But when digitization came, now what is there? I record, that is stored by converting into analog into digital. I am speaking. The speech signal is converted to voltage signal. The voltage signal is sampled, and each sample is stored using some number of digits. Now memory is so huge that, and ADCs are also so easily available that losing something is just out of question. So that is stored in digital sequence, and that digital sequence is taken by a computer, worked on it, converted into another digital sequence, that is fed to digital to analog converter, and I hear the sound back. Only thing is that there can be a good science fiction animation that human beings don't understand digitally. That I talk, which is analog, and I listen, which is analog. So if that kind of, just like now you may have read somewhere that Elon Musk is going to put some chip into human brain. Like that, if something is put, and that ADCs and DSCs are part of human beings' system, then things may take a drastic turn. So the point here is that nowadays system are digital systems. So signal is continuous signal fed to a physical system, it produces another continuous signal. Then continuous signal is sampled, a discrete signal is digitized, stored in computer, processed by computer, converted to another sequence, that is converted to analog, that is the output. And remember that discrete signal cannot be processed except by human intellect mind. Right? So in term means in discrete signal, amplitude is continuous, time is discrete. So signal continuous, sample to discrete, and further quantizing a discrete number into a digital number is digital, means expressing using some digits, digital signal. Then it is physical system. Continuous signal is input to a physical system which generates another output signal. So what is system? Which receives one signal, and based on the signal and some kind, means I teach you, you learn something. So your learning is an outcome of my teaching and your own understanding on it. So your final picture, final state depends on what I teach and what you perceive. So a continuous signal is given to a physical arrangement, maybe of using some pulleys, maybe using some valves, maybe using some jacks, maybe using some physical arrangement, maybe using some springs, maybe using resistor, capacitor, inductor like components, amplifier like components, and output is again a continuous signal. So what is a system? To which it receives one input signal and produces other output signal in some structure mechanism. A mad system will produce something which has no relevance with what is being received. A corrupt system, a mad system. But a normal system will receive a signal which is a function of time and will produce something a function of time. Both variables may be same, both variables may be different. Means for amplifier, voltage input, voltage output. But for a, what we can say, thermocouple, voltage, temperature is input, voltage is output. So some parameter which is continuous is input and some other parameter or in the same parameter with some different form is the output. So voltage input, voltage output. Voltage input, current output. Pressure input, voltage output. Voltage input, pressure output. So these are physical systems. Discrete systems we right now don't discuss. Digital system is a computer. Computer means simply a program and it produces digital output. A digital sequence is received by computer, converted to another digital sequence, and discrete can only be processed by human being. So discrete can only means discrete is an array of numbers. This is continuous mapping of numbers. It is continuous function. This is array of numbers. Array includes distinct numbers which are continuous. So array element 0, array element 1, array element 2, array element 3. So this is expressed as xt. This is expressed as xn. And this is also, there is some way cap n were digitized, but that is not so frequently used because this is just hypothetical, doesn't exist. So same logic is used, means discrete time signal processing is for thinking, and when implemented we implement digital, and the difference between digital and discrete is so negligible that there is no need to consider that. So the thing is, in discrete it is array of numbers, each variable is a real number which is continuous, which is having infinite resolution. In continuous, again infinite resolution. And another thing is, the other variable with which it is mapped is also continuous. So it is a two-dimensional graph, a function of one variable with other variable. This is a bar chart. On time axis, only distinct samples are used. These may have infinite resolution values. Those can't be numbered. You can't express them using digits. Whereas when you approximate it, so you decide now how many digits I would be using, how much resolution if I am having length, then centimeter resolution is enough, millimeter resolution, tenth of millimeter, or micrometer resolution. So you decide how many digits you are using to express that. And then when you decide to resolution, suppose if you decide that I will be using 4 digits, 0.000 to 9.999 to express 10 meter. If you are having 10 meter length, then you can express it using 0.000 meter. So first is meter, next is decimeter, next is centimeter, next is millimeter. You are having a millimeter resolution. So in 4 digits you are expressing using millimeter resolution, then the maximum length you can express is around 10 meters, 9.999 meters. If there is 20 meter length, then this scale is of no use. You will not be able to express. So what you have to decide is, when you are having finite number of digits, you have to define how much resolution you want and how much maximum size you want. If you want to have lesser resolution, for the same digit there will be what we can say finite size, which will again less. If you want to be poorer in resolution, you can express larger size. Then there can be a logarithmic scale also. Right now all those details are not so relevant. The theme is that when we digitize, the resolution is finite. So continuous, I am trying my level best to explain this. I want to emboss continuous, or it is called also analog signal, or instead of continuous you can use analog term. So continuous, a variable with infinite resolution defined continuously is analog signal. A variable with infinite resolution defined at sample instances is discrete signal, and a discrete signal converted from infinite resolution or discrete samples of infinite resolution converted into finite resolution is digital signal. So continuous signal, discrete signal, digital signal. So from continuous processing to discrete processing, we come to know that there is no need for me. If we are having continuous processing, then we must be engaged ourselves in all continuous functions like derivative, integration. When to study the system, I should go in continuous processing, and derivative and integration, convolution, one of them is involved there. Whereas when I come to discrete, I get numbers, I get array. So in array, index is integer and value is real. In an array, xn, so n is integer, 0, 1, 2. It can be on minus side also, because it depends upon where you define 0. So index is an integer and actual value of that is real. In case of continuous, both are real. And in case of discrete, the index is integer, value is real. In case of digital, index is integer and value is also some bit or some digit combination. So continuous systems, physical systems like a simple RC circuit. So the best system what we discuss is this one. Input, output. Discrete system doesn't exist. It exists in your intellectual plane. And this is computer. I hope it is quite clear now. Then when a signal is said xt, means at every t there is some temperature, at every t there is some height of a plant, at every t there is some voltage somewhere, at every t there is some atmospheric pressure on me. So all these are single dimensional variables. But yesterday specifically I told you to think in a two-dimensional simultaneously. Thinking of two-dimensional simultaneously is just like our stereo vision. If you are able to watch through one eye and then through other eye, the images watched separately don't have that much impact. Means you can watch with this, then you can watch with this, and then if you want to correlate separately, it is difficult. But what you watch with both eyes is having a different impact. Like that, thinking in a two-dimensional mode is a completely different and drastically enhanced thing that also will elaborate. So the concept of two-dimensional signal, and remember you will find it after a few lectures, signals and systems is entirely hypothetical subject like mathematics. It has nothing to do with electronics. After a few sessions you will come to know that signals and systems entire subject has nothing to do with electronics. It is entirely mathematical analysis. And so from that point of view, what is a signal? We consider position of a point moving on a 2D plane is a signal. It is hypothetical. This signal is applied input to some system which works on it in some manner and produces, means suppose that there is a laser beam which is being produced here, and based on that there is one more laser beam, so that will move in such a manner which will depend upon the movement, this movement and some function. So after some time, position in a 2D plane is input, you work and you come up with position in 2D plane as the output. So two-dimensional input, two-dimensional output. So x in t or xt as input, yt as output. What is xt? xt is a moving point. Remember, I again repeat, xt is a moving point in 2D plane. And yt is also moving point in 2D plane. So on this side, input is there. So there are two parts. There are two parts. Here, using a red laser beam, you will put something and you will observe that on this sheet, a blue spot will move. The movement of this is taken as input, and with some kind of processing, that is output. So remember, xt is input, yt is output. If you sample, xn is input, yn is output. If you can digitize, again same thing, where xt is not one real number, but being two-dimensional, it is having two real numbers. So what we can have, x horizontal t, I am using h and v because x and y I have already used. So x horizontal t, x vertical t, and y horizontal t and y vertical t, or x r t and x theta t, and y r t and y theta t. So I want to emboss on your mental plane that a signal, what is a signal? Signal is position of a point in 2D plane which varies as time. So what is xt? The point, a red spot located somewhere in 2D plane, and as t proceeds, the spot will move anywhere in the plane. So xt and yt. So, or in general, signals are moving points in 2D plane, that is the position signal. Why at all these things are so important, why I am stressing on 2 dimensions, everything that I will explain for that purpose. So I hope signal and system. So system receives input signal. Now you can think of a hypothetical system. You can think of a hypothetical system. Every system need not be realizable. Human beings' ability to imagine something which can't be realized today. Einstein has imagined that in 1909, Einstein has postulated that the phenomenon of light rays bending near heavy mass can be observed after 14 years at the time of total solar eclipse. So that should be the, what we can say, motivation for you to think at a larger context. So now the idea should be very much clear that a signal means some variable and that is applied as input, and you obtain some output. You obtain some output out of it. Now, what is a system? We elaborate in general. So 2 dimension is okay. You need not think always 2 dimensional, but you try to think. I will elaborate all those things when we go for 2 important things in signals and system, that is E and J. So a proper understanding of E, J and S, which includes sigma and omega, or that sigma and omega are not so important. So E, J and S, entire signal system syllabus you will find is revolving around this, and many times you will be getting omega, sometimes sigma and n, x and xn, yn or xt, yt. So in this you will be confining yourselves. So in the next session I will elaborate in detail on these 2 phenomena after some time. But prior to that, what is system? So if we think of a voltage signal, I am trying to explain it in most simple manner now. Let us have voltage signal, V in T. I am sure that every individual from this class is having a perfect pseudo understanding of voltage signal. What is pseudo understanding? It is a field where one thinks that he has understood even though he has not. But sometimes pseudo feeling is also important, because if everybody starts thinking on the reality, then the life would be miserable. So like that, understanding electronics is one such thing which will make the things miserable. If you start thinking on everything and find yourself in a miserable condition where you get a perception that you don't understand anything. Therefore, V in T, you are having a proper understanding now. Let us say pseudo, but let it be proper. Now we are having a simple system where I am having 2 resistances. So now there is a common ground. In fact, actually what is common ground and all that, some time is needed, but right now we don't have. I will elaborate in some extra session later on. So it is common common terminal, so this is V in T and VOT, and I have got two resistances. I have got two resistances in the system, R1 and R2. R1 and R2. So what is the output? VOT is equal to R2 upon R1 plus R2 into V in T, where input is a voltage signal, output is also a voltage signal, and input and output are related by a simple formula where output is some constant times input, that is called as an instantaneous system, or that is also called as, in scientific terms, zeroth order system or zero order system. Zeroth one may not like to utter, zero order system, let us say. Instantaneous system where output is proportional to input directly. Output is scaled version of input. This is zeroth order system. So this is simple system, so nobody calls it to be a system, which is never given example of. Now most important, which we had discussed in the first semester in circuit theory, but that is again relevant here because now we are considering it with system considerations and not what we can say a simple consideration of input output, finding output for given input like that. We are trying to analyze it from a different perspective, even though in the first semester we still went into details, but we will try to focus more details. So, and again, for simplicity we take values simple. We don't put R and C. We put 1 farad because, and we put 1 ohm and V in T and VOT. Now what happens is a very interesting phenomenon happens. For capacitor, what kind of relationship we have between voltage and current is that current is proportional to derivative of the voltage across the capacitor. Current is proportional to derivative of voltage across the capacitor. Then by using Ohm's laws and Kirchhoff's laws, it is possible for us to find out the expression for input and output. Since we discussed it in the first semester, I am moving rapidly. What will happen is V in T minus VOT upon R, which is 1 ohm. This is a series circuit, and as it is a series circuit, what will happen? The current will be same, IT. So resistor current is V in T minus VOT upon R, which is 1. So it is IRT. Resistance current is IRT. And what is ICT? ICT is C dVc by dt, where Vc is VOC is 1. So ICT is dVOT upon dt. And since it is a series circuit, IRT equal to ICT equal to IT, therefore we must get dVOT upon dt is equal to V in T minus VOT, and if you take VOT on the other side, we get the expression as dVOT upon dt plus VOT is equal to V in T. So here what is important is that we have got a system in which there is dependability of the output but not directly on input. There is a complex nature. So this differential equation is to be solved. And by solving this differential equation, by solving this differential equation, you will come to some VO. You will come to some VO which will depend on VI in a very peculiar manner. In previous case, what we were having, we have got VOT. If in that case R1 and R2 both are 1, then is equal to half V in T. So output was depending upon input at that instant by some constant of proportionality. Now in this case, if you solve this differential equation, you will be getting an integral that is called as convolution integral. This convolution we will be discussing in detail. This convolution is crux of this. But what happens is, it is somewhat difficult to understand. Integration is not means if a survey is made of the entire scientific community in the world who are exposed to mathematics, and a question is asked out of many mathematical processes which process they think is very difficult to understand, and the answer would be unanimous, and it is integration. So this is not so easy. We are not skipping it, but we would be keeping it aside, because instead of exposing you to the complex process, it is possible to expose you to a simple process. Now, what we will do, that we want to establish this relationship. So now it is just like, say, performing some calculations 50 years back, a very complex mathematical sum. Just like, say, compound interest or finding EMI. Say you are very much exposed to media, then say that SBI reduces interest rates on home loans, so EMI is reduced. Then I give you one assignment. If the housing loan interest is, let us say, 12%, it's too high, just I am giving simple example. You take housing loan of 10 lakh, interest is 12% per annum, means 1% per month, and you want to repay that housing loan in 20 years, compute EMI. And I think that before tomorrow, everybody of you should be able to compute. Simple question. Housing loan 10 lakh rupees, interest on housing loan is 12% per annum, that is 1% per month. You take housing loan on 1st January of some year, then first installment you pay on 1st February, and such you will be paying 240 equal monthly installments. Find out equal monthly installment such that the amount of 10 lakh is refunded, and a principal amount of loan taken on 1st January 2021 is refunded fully on 1st January, last installment, 1st January 2041. Equal installments are monthly, and the amount taken is 10 lakh, the interest rate is 12% per annum or 1% per month. The example which I am giving right now, I have spent around 2 to 3 minutes on this, because it is very difficult question to be answered. With all kinds of computerized tools, you try to find it out, and I am sure that it would be very difficult for you to find it out. I would be very much happy if I am proven wrong. So, for such complex calculations 20 years back, it was difficult. But now, you take help of calculator, you take help of Excel sheet and all these things. Like that, so finding out expression for VOT, for VET was not so easy. But now, what you can do, you can apply VET, you can observe VOT, but it is not that you observe. You will put ADC, DAC, and you will record everything. You start the system, and after the things are nowadays, means even 30 years back, to get Epson calculator, scientific calculator, it was for 400 rupees. Now also it is less than that. So the cost has reduced, and the, what we can say, same computing power is available. So right now all kinds of ADs are available. What you will do is each microsecond you will take a reading. So you start the system and you will take reading each microsecond. So what you will note down? V in N. You note down. You will also note down VON. So this is input. You have connected one ADC here. You will record all the values. You start the system. You will apply some input that will be recorded by sampling and digitizing. You will also record the output by sampling and digitizing. Such 1 microsecond per one, each microsecond will take sample. So in 1 second there will be 1000 samples. 10 seconds, 10,000 samples. You have huge memory. 100 seconds, 1 lakh samples. You can store that very easily. So you will store that information, and then you will try to correlate the information effectively. So instead of processing in continuous domain, my point is processing in discrete domain is somewhat easier. Right now it is not in the syllabus. In some branches it may be. Few years, maybe few decades back, numerical computational methods was one popular subject, but now it is so easy that it is not kept as a subject. It is part of this discrete time signal processing itself. So, and again I repeat that discrete and digital, the difference is negligible. So discrete and digital we also use interchangeably. So V in N is actually a discrete variable, but when stored in the computer it becomes digital variable. So that difference we ignore. So V in N and VON. So with this then, so what I am doing, V in T, voltage, current, resistor, capacitor, VOT, there is some kind of relationship, differential relationship, derivative. Derivative is somewhat easy but not so easy to understand, and its reverse process of integration is very difficult. But instead of derivative, difference is very easy to understand. So array processing is extremely simple as compared to continuous processing. So we go with array processing. So what I am doing, and in array processing there is approximation, but that approximation is negligible because my sampling interval is very less. I am sampling at such, in fact actually the digital camera resolution is poor instead of continuous camera. But because continuous camera is analog, infinite resolution, but so huge resolution, or huge means so fine resolution the cameras provide that the image which is discrete, my eyes are unable to distinguish the pixels. So pixels which are there on screen are actually distinct, but the mixing is automatically done in my eyes that view the mobile image which sometimes looks more clear than actual view. Pratyaksha huni pratima utkat. So that you can have. So that discrete and digital resolution is negligible, and the continuous and discrete approximation is also negligible because you can sample at sufficiently faster rate. So if V in N are the samples of the voltage after time interval T. So V in N is voltage at V in, so what is V in N? V in N is equal to V in T at T equal to N capital T, and capital T I am using as 1 microsecond. So in this case, how this equation we can write? What is IT? IT would be IN. V in T, I have V in N, I have VOT as VON. I have VOT as VON. Then what will be IRN? Same way, IRN is same as IRT, same expression, V in N minus VON. V in N minus VON. What is ICN? What is ICN? ICN is C dVOT by dt. ICN is C dVOT by dt. What is C? C is 1. So ICT was dVOT by dt. dVOT by dt. So it's a derivative. What is dVOT by dt actually? By the first principle, dVOT by dt, what is the derivative formula? What is f dash x? F dash x is f of x plus h minus fx upon h as h tends to 0. F dash x is equal to f of x plus h minus fx upon h. Or to be more precise, what is dy by dt? What is dy by dt? dy by dt is y of t plus delta t minus y of t upon delta t as delta t tends to 0. So delta t is sampling interval. If I sample at sufficient fast rate, I can say it to be, instead of delta t, I can say it to be, let it be delta t right now. I will explain. Then the problem is, here I want one correction. I don't know why designers thought of this. F dash x equal to f of x plus h minus fx upon h. In fact, this formula I want to change to some extent. Do you agree that it's not a major change, but it's no doubt it's a very required change. So I want to change it as f of x minus f of x minus h upon h. It looks more realistic because it is something ahead, whereas it is something behind. Both are same. So this formula would be y dy by dt is yt minus y of t minus delta t upon delta t. Yt minus y of t minus delta t upon delta t. So if I sample nth sample, then dy by dt, and this is limit as delta t tends to 0. If delta t is sufficiently small as capital T, then dy by dt will be approximately equal to y of t. What is y of t? It is y of n, current sample. Y of n. Y of previous sample where t is equal to n capital T. Where t is n capital T. And what this would be? Delta t is t. Delta t is if delta t I am using as sampling interval very small equal to t, then yt is yt is ynt. This is ynt minus t. So this would be ynt minus ynt minus t. So this is ynt minus yn minus 1t. So nt is nth sample, n minus 1t is previous sample. So I can write down that dy by dt is equal to yn minus 1 upon capital T. So this is approximate equivalent. So in this case then, what would be ICT? ICT is this. So this I will say as, so, and then this would be derivative. So ICN would be dVO. This is derivative in difference equation. That is dy upon dt is approximately equal to this. So ICN would be equal to VON minus VON minus 1 upon capital T. So ICN is VON minus VON minus 1 upon capital T, and these two, since it is series circuit, what should happen is that IRN and ICN must be equal. IRN and ICN must be equal. Therefore, what you will be getting is VIN minus VON is equal to VIN minus VON is equal to VON minus VON minus 1 upon capital T. So this capital T will multiply on this left hand side. VIN minus VON is equal to VON minus 1 upon capital T. So with this capital T we multiply here, and VON we take on this side. VON we take on this side. So minus T VON, this comes on this side, minus VON, this goes on the other side, is equal to minus V in N into T minus VO N minus 1. So multiplying by everything minus T plus 1 into VON is equal to T V in N plus VON minus 1, or VON is equal to T upon T plus 1 into V in N plus 1 upon T plus 1 into VON minus 1. So this is the most important expression in systems, in discrete systems, where current output is a combination, a linear combination, means something